Hi class, welcome to another lesson. This is going to be our last lesson of chapter 3, so you can anticipate a test coming up very shortly. So today's lesson is on linear programming. And class, I just want to prepare you for this. This is a difficult lesson. It's not easy to do. So make sure that you pay very close attention, take good notes, and please ask questions on something that you don't quite understand when you get to class tomorrow, because I really want you to understand all this, and if something doesn't make sense to you, please ask me. What we're going to do when we do linear programming is we're going to follow these 7 steps. Most of them are pretty simple, but there are a couple really tough ones that can make the question very difficult, especially number 2. So the first thing we're going to do is we're going to define our variables. That's pretty simple. And then we're going to write a system of inequalities, and this can be very difficult. Along with number 5, we're going to write a function to be maximized or minimized. This is kind of tough because it definitely takes a lot of understanding of the problem. There's some math problems that you can kind of do without even thinking about it, or without really even knowing what the significance of what you're doing is. But for linear programming, you have to have a very good knowledge of exactly what is happening in the problem. So after we write this system of inequalities, we're going to graph them. We know how to graph inequalities. We're going to find the coordinates of the vertices. We did that last lesson. That's no problem. Number 5, again, is going to be a tough one. We have to write a function to be maximized or minimized. But once that happens, now all we're going to do is we're going to fill in that chart by substituting in the values and then select the greatest or the least result, which is that what's the minimum, what's the maximum. So a lot of this is going to tie in everything that we've done with our graphing inequalities and then doing our bounded region, so on and so forth. So for our first one, it's very important, class, that as we read this part, we got to understand exactly what is happening. Don't daydream as you're reading these. Don't kind of ignore some things thinking that it's not important. Basically, every single word in this paragraph is important, so understand it. As a vet, so veterinarian, Brynn, she has her receptionist schedule appointments. She allots 40 minutes for a surgery. So this dog needs a surgery, it takes 40 minutes. This cat has a surgery, it takes 40 minutes. And 20 minutes for a routine office visit. So just, the regular ins and outs, 20 minutes for that office visit. Brynn cannot do more than 6 surgeries a day. Evidently, she can only handle so much. It's probably a little bit more stressful. She doesn't want to have too much of a crunch on getting things done, so she only allows 6 surgeries in a day. The office has 7 hours, which is a total of 420 minutes, 7 times 60 minutes, a total of 420 minutes available for appointments. Most jobs, I suppose, go like 8-hour days, like teaching is an 8-hour day. If you're full-time, you work 40 hours a week. That would be 5 days at 8 hours a day. Evidently, Brynn, as a receptionist, she only works 7 hours a day. If an office visit costs $55 and most surgeries cost $125, find a combination of office visits and surgeries that maximizes the income Brynn's vet practice receives per day. Brynn is a businesswoman, right? In a capitalistic society, she wants to work as hard as she possibly can and do as much as she possibly can do in order to maximize her profit. She wants to make money. So she wants to make as much money as possible if it costs $125 a surgery and $55 an office visit. So I hope that paragraph made sense to you. So step 1 is going to be defining our variables, which in our lessons, it's actually quite simple. You can see on your chart, your x-axis and your y-axis. What does it say on your notes? Your x says that it's surgeries, doesn't it? And your y says that it's office visits. So under step 1, or under letter A, defining our variables, it was kind of already done for us. Our x-axis is going to be the number of surgeries per day. Number of surgeries per day. And so then obviously my y variable would be the number of office visits per day. Alright, step 1 is done. Step number 2, this is a very difficult one, which on your notes it's letter B. Write a system of inequalities. So write a system of inequalities. All right. I suppose the first two that you're probably almost always going to see on these problems are these two. Is there any way that you can do a negative number of surgeries? There isn't, right? That's just silly. Okay? You can do 0 surgeries. Brynn can do 1 surgery, 2 surgeries, 3 surgeries, all the way up to 6. So I know that she's going to do at least greater than or equal to 0. So my surgeries has to be greater than or equal to 0. My x value, which is the surgeries, x has to be greater than or equal to 0, because there's no way you could do a negative number of surgeries. Likewise for office visits. It's not like she's going to do a -1 office visits, right? That's just silly. We know that she's going to do more than that. So y has to be greater than or equal to 0. So these two you're almost always going to see in every one of these linear programming problems, because there's really no way of doing a negative number of these jobs. All right, so now we're going to go on to our next one. Let's see what we find here. Well, this statement right here, Brynn cannot do more than 6 surgeries in one day. So she's not going to do 7. Her receptionist won't schedule in 7 surgeries. Her receptionist will not schedule in 11 surgeries. It's going to be 6 or less than that. It could be 5, 4, 3, 2, 1, or 0. So I know the greatest is 6. Everything else has to be less than. So my surgeries, which once again is my x variable, my x has to be less than or equal to 6. She's not going to do more than 6 surgeries. So that's going to be another one. You have one more inequality that has to be done, and that's because she's not going to do, 6 surgeries and, 50 office visits. That's too much to schedule into a 7-hour day. She's only going to work 420 minutes, right? So now, let's erase some of this writing here, because I could see how it might be starting to get confusing. She allots 40 minutes for a surgery. So if she does 1 surgery, 40 minutes. If she does 2 surgeries, 80 minutes. If she does 3 surgeries, 120 minutes. However many surgeries she does, she multiplies it by 40. So it's going to be 40 multiplied by x. 40x. Because x is the number of surgeries. She allots 20 minutes for a routine office visit. So if she does, 3 office visits, that takes her 60 minutes or 1 hour, because 3 times 20 is 60. If she does 2 office visits, that's 40 minutes. You guys get the pattern. However many office visits she does, we multiply it by 20. So it's 20 multiplied by y. Now in a day, she's only going to do office visits and surgeries. So if you add up the length of time that it takes her to do the office visits and the surgeries, so it's the sum of those two, it has to be less than or equal to, how many minutes does she have in a day? She's only going to work 420 minutes. So it has to be less than or equal to 420. That was the most difficult one to find, in my opinion. She's going to do 6 or less surgeries, and they take 40 minutes. So if you multiply that by the number that she does, and add that to the amount of time of office visits she does, which is 20 times y, it's going to be less than 420, because her receptionist will not do anything more than 420. Just won't schedule that. Whew! As you can see, step 2, or in your notes, step B, is very, very difficult. You have to have a good comprehension of exactly what is happening. So now, what we're going to do is we are going to, step number 3, is graph our system of inequalities. So, let's graph these two first in class. If x is greater than 0, that's everything to the right of here, because x equals 0. So it's going to be everything to the right. And then if y is greater than 0, it's going to be everything above the x-axis. So everything up in here. So what I'm telling you, class, is that you really don't even have to worry about quadrant 2, 3, and 4. Your solution is going to be in the first quadrant, okay? Because x is greater than 0 and y is greater than 0. So with that being said, let's now go on to this one. X is less than or equal to 6. An x equals line is a vertical line and it's going to be at 6. So these go in increments of 4. So 6 is right in between 4 and 8. So right here, we have a vertical line at 6. Let's see how straight I can make this. Okay, there is 6. I suppose I could have maybe brought it over just a little bit. Come on, sugar. Maybe there? Okay, and I know that it has to be less than or equal to 6. So it's going to be everything in here. So you've graphed 3 lines so far. X is greater than or equal to 0, y is greater than or equal to 0, and x is less than or equal to 6. So now this one is going to be our big one. 40x plus 20y is less than or equal to 420. You can put this into slope-intercept form, or you can put it into standard form. It really doesn't matter, I guess. We'll put it into slope-intercept form. So it's going to be, subtract the 40x. We have 20y is less than or equal to, now a negative 40x plus 420. So now if we divide by 20, we know that y is less than or equal to, a negative 40 divided by 20 is a negative 2x plus 420 divided by 20, I believe that is 21. Doing it in my calculator, and it is indeed 21. So this is what we're going to graph for our fourth equation. Y is less than or equal to a negative 2x plus 21. So you're going to have a point at 21. Your y-intercept is 21. And then your slope is down 2 to the right 1. Your slope is a negative 2. Now class, I understand that these go in increments of 4. But if you still go down 2 whole blocks on our graph, it's actually like you're going down 8. And if you go to the right 1 block, you're going to the right 4, which isn't a negative 8/4 the same thing as a negative 2 over 1? It is, so you don't have to worry about, they now go in different increments. You could still go down 2 over 1, because it's the same, that's the same thing as going down 8 over 4. So down 2 over 1. Down 1, 2 over 1. And let's just draw this straight line right here. Did I do that right? Down 1, 2 over 1, down 1, 2. Well, we'll see what it looks like. I guess it more so, yeah, I didn't go to the right far enough on that third dot. Something that looks like that. This blue dot class, sorry, shouldn't be here. Down 1, 2 over 1, down 1, 2 over 1. It should be more about right in there. All right. And then this shading is everything that is less than. So it's going to be below that line. So I'll shade it in red here. As you can see here, class, I don't want to make a huge mess with this. This section right here doesn't have any green in it. So I know that's not going to be part of my solution. So my solution is going to be everything that is right in here. That is my solution. That's going to be my bounded region. This satisfies all 4 equations that I wrote in step B. All right, so you have like a trapezoidal type figure right there. So with that, let's find our 4 vertices. One is right here. One is right here, one is right here, and one is right here. Now this step can be a little bit tricky, finding where that is. We know this point is at 0, 0. Now let's talk about where this point is. We know that Brynn can't do any more than 6, so that x is less than or equal to 6 was this right here. So I know that that is right 6 units. And it's right on the x-axis, so it's going to be at 6, 0. We know what our y-intercept was for this line right here. Remember that was 21. So this is left and right 0 and up 21. So that's that point. Now this point is a little bit trickier to find. I don't exactly know where that is. I can kind of approximate. It looks like it might be at 6 and maybe 8 or something like that. But because I don't know for sure, what I have to do is I have to put a value that I do know for sure into this equation. That might sound confusing at first, but here's what I mean by that. This point right here, I know what my x value is. My x value is 6. Why do I know that? I know that it lies on this line, which is the line x is less than or equal to 6. So my x coordinate is 6. I'm not exactly sure my y coordinate. It could be 8, but it could be 8.5. It could be 9. It could be 10. There's a lot of different things that it could be, all depending on how straight I drew this line right here. So what I want to do, if I know that it lies on this line, what I could do is I could just put in 6 into this x variable and calculate what my y variable is going to be, because that's what I want to find. I want to find my y variable. So 40 times x, which is 40 times 6. I'll probably do this at the very bottom so I can get out of your way. 40 times my x value of 6 plus 20y. I want to find what y is. That's going to equal 420. I know it lies on that line. So 440 times 6 is 240 plus 20y equals 420. 420 subtract 240. We get 180. So 2y equals 180. And then I divide both sides by 20. So y equals 9. 180 divided by 20, y equals 9. So now I know for certain where this point is. It is at 6, 9. All right, you have your 4 points. Let's put those in our chart. 0, 0, 6, 0, 0, 21, and 6, 9. All right, step number 5, which is our next tricky part. Write a function to be maximized or minimized. So this is oftentimes done in a dollar amount for these linear programming problems. An office visit costs $55. So if she does 1 office visit, she makes $55. If she does 2 office visits, she makes 110. 3, so on and so forth. So however many office visits she does, she's going to multiply it by 55. And the same thing with surgeries. However many surgeries she does, she's going to multiply that by 125. If she does 5 surgeries, 5 times 125, that's how much money she makes, so on and so forth. So my surgeries is my x variable. So 125 times x. And the money that she makes in a day is combined with her office visits and her surgeries. Her office visits are 55 times y. This equation tells her how much money she's going to make in one day. 125 times the surgeries plus 55 times the office visits. That tells us how much money she makes in a day. So 125 times 0 plus 55 times 0. We could put this up here, I suppose, so that we could look at it. 125x plus 55y. So obviously, class, if she doesn't do any surgeries and she doesn't do any office visits, she makes $0. It's like she's going on vacation that day, I guess. Nothing. If she only does surgeries, 125 times 6 plus 55 times 0. If she does only surgeries and no office visits, she is going to make $750. $750. If she decides, I don't want to do any surgeries today, 125 times 0, and only wants to do office visits, plus 55 times 21. Oofta. 125 times 0 plus 55 times 21. that 7-hour day is going to give her enough time to do 21 office visits. If that was the case, she would make 0 plus 55 times 21 is 1155, $1,155. Now, if she were to do 6 surgeries, which is the most she can do, 125 multiplied by 6, and she were to do 9 office visits, so that would pack up her day. 55 times 9. She would make a total of, adding those two up, 1245, $1,245 that day. So then, lastly, select the least or greatest to answer the question. She would make the most money with the 1,245. And now be very specific when you answer this question. Brynn would maximize her profit if what happened? Don't say the order pair being 6-9. I will not give you full credit. You'd say Brynn would maximize her profit if she did 6 surgeries and 9 office visits to make a total of how much money? $1,245. This is how specific I want you to be when you answer these questions, because it's not just a simple math question now where you give me an XY order pair. I want you to make some sense of that XY order pair. So class, if you take a look at this chart for a second, she's going to make the most amount of money if she does as many surgeries as possible, because those are the ones that are worth the most amount of money. And then she packs the rest of her day up with office visits being 9. Now class, even though that's the most amount of money that she could make in one day, let's just think about this for a second. She might get pretty drained if she does this day in and day out, day in and day out. Maybe an office visit is quite a bit easier than doing a surgery as far as on her body, as far on her mind and stuff like that. She might want to just do, you know what? One of these days, all I want to do is office visits. Maybe it's a Friday, I want to take her easy. She'd still make quite a bit of money, wouldn't she? Only maybe, $90 less or something like that. So that could be an option for her on some days as well. There might be some days where, you know what, it only takes, 40 minutes to do a surgery, whatever the case might be. I only want to do 6 surgeries. She would still make $750. She could take the afternoon off or something like that. So these are good things to ask yourself when you are an entrepreneur, when you are a businessman, businesswoman, whatever the case might be. Good questions to ask yourself. But if you want the most amount of money, you're going to pack your day up as much as possible, and you're going to make $1,245 a day in this particular case. The next one, we have a what do we have here? A landscaping company. I want you guys to try this one all on your own. I'm going to record a separate video where I'm going to go a little bit quicker than on this video, just to save some time, and hopefully you guys can have some success doing this one. But please let me know if you have any questions, and watch the video on this one to make sure that you did it right as well.